Currently for this list, I have increased the number of users that we have inside, right? So you can see the list. If I scroll down, there are so many. I gathered about 30 of them, right? So I just give it to AI to be able to increase the number of users in this list for me. Right? So these are my original ones, and we have this. So let's try what we had originally again. Let me try W this time. Yeah, so there are some people that have W parts of the list. Let me see L. Yes. Q. There's no one for Q. O. There's O. K. Yes, there is K. X. There's no X. C. There are some C's. Z. Yeah, there are some Z's. Okay. So now, if you have a very large list of items, like about 1 million lists, a very huge number of lists, and then you are going to be searching from them, especially when you are doing a search and the search needs to come directly from an API or a backend, which is also relying on the internet to run, right? Every single key that you type, like if you type V, for example, this V will be sent to the API and the API will go and fetch the items, right? Then you tap E, then you type R or T or whatever, right? Now, every keystroke that you type will call an API, will call the system to filter every single key that is, and then that's going to actually affect your performance if you don't add something to it. What we want to add is that, okay, we need to wait for the user to finish typing their thing. They need to finish typing everything they want to type before we send the RAM filter system to go and actually search through the thing for us and get at what we want. So we are going to actually introduce a simple delay, right, between when the time that the user is typing and the time that they are done typing. So when the user is done typing, we wait for some few milliseconds before we use the results to send, instead of waiting for every single stroke like key. So every single key that enter, there's this thing. You can see that on the on change. When we are doing the on change, where are you? Where are you? Um, inside here, you see, once every single value change, this thing will run. If you add any new value, this thing will run. Okay, it will be changing, it will be calling the search through all the time. But if the list is very huge, we cannot, this is not efficient. It's going to really lag your system and people will stop using your app. So what is the solution? The solution is to add a debouncer. We are going to add a debounce function. What the function does is that it waits until it helps you to wait until the user is done typing. Then from there you can now proceed to send the request to the API or the backend or even through your own system, right? Because you might have a very large group of items to do. So the efficient way of doing all these things is that always add a debouncer to your search, right? If the list is very, very small, maybe don't worry, and it's not depend on the backend or API directly, then no worry about that. But if to be safe, why don't we just add a debouncer? So now let's look at how to set up the debouncer. So what we are going to do is that we are not going to directly search through. So we are going to write a function on top of this, right? And in that function that will be calling the search through. But before that, we need to actually deal with the timer. So to deal with the timer, you need to work with timer in Flutter. We need to go the top here, right? This is where we do all our imports. We need to import the async, right? So import that async, right? This is very important. We use it in time. So whenever you are using time, right, this import will be, we have not used it here, that's why it's giving us that error. So no problem yet. So this is our list. Let's go to the bottom of our list, our large list, and then we have filter users. We've gone through this any state, the search through function, right? On top of the search through function, we want to add some stuff, right? So we are going to add a debounce timer. So it's going to be like a debounce is going to be like a time that you are going to add, but then This is timer, right? Debounce. You know why we are doing the question mark? Because we want the debounce to be able to accept null values. So when it is null, we know that okay, it's not running. It is not running. But if it is running, then the value will not be null, right? So now we'll see it in action soon. Now, that's just a debounce variable, but we need to be able to put a function on top of it, right? So we are going to say, um, how are we going to call that function? So let's call it void debounce function. The debounce function, because, or let's say delayer, right? Let's call it delayer, because there's a function that will delay whatever this is, and then we are going to take string the query, like the query or the keyword that the person will enter, right? So let's call it query keyword as well. You also take the key. Based on every key, it is going to run this particular function. So this is a delayer function, right? So it's going to delay first. Check the delay first. But then how do we run that? So first, when we start, we need to check if the debounce function, debounce variable, which is here, is null. Currently it is null, right? If you don't assign it at the beginning, it is null. And then the question mark makes this function accept a variable, a null value. So when the debouncer is set, when the timer has started, right? When the timer starts, what will happen is that you will have the debounce will no more contain null, right? So whenever someone starts typing, when the user is typing currently, we need to be able to cancel the debounce. But let's say we set like 1 minute. Within 1 minute, when the user stops, and then there is after 1 minute, we want the API to wait for 1 minute before sending it. Let's say the user enters a key now, and then after 30 seconds they add another key. So it means that the system is waiting. Whenever the user types something, the system will wait. Every new key, the system will restart waiting. It will restart the timer, right? Every time that a new key enters. So if it's 1 minute and the user enter a key now and stops, then the system will be counting until 1 minute, like 1 second, 2 second, 3 second, 4 second, until it gets to the 60th seconds, or that's 1 minute. But when it is now 5 seconds and user enter another key, then timer needs to restart again back to um like to restart again, counting 1, 2, 3, 4, 5, 6, 7. When the user enter a key along the way, is going to restart again, because we want to wait for 1 minute before we send the request. If after 1 minute, then we are sure that okay, the user is no more entering anything, so let's send it up. I'm using 1 minute because I want you to understand the whole flow. But then we use a very small time, like 1 second or half a second, 1 second or half a second, right? So if it's 1 second, we are going to count between milliseconds. So 1 millisecond, 2 millisecond, 3 millisecond, 4 millisecond, 500 millisecond, and 500 millisecond. That will be like half a second. So it's a time. So what you have to do is that when there's nothing that enters, and then that is entered after 500 milliseconds, then the function will now proceed to go and then do the search for us, right? That's what happens. So now what we are going to do is that whenever a new key enters, we need to check if the timer is currently running or not. How do we know the timer is currently running or not? Meaning that it will not contain a value now. It will not be now, right? So let's check if a new key is entered. Check if the debounce timer is currently running, right? Let's check if it is currently running already. So if it is currently running and a new key has come, what should we do? We should restart, right? So how do we check that? So we are going to say if debounce is not equal to now, right? Because if it is now, then we know that okay, it is not started. But then if it is now, if it is not equal to now, I mean that okay, it has started counting, right? They have started counting. So you understand. You need to understand that we are checking if the debounce is not now, because if it is now, it means that it's not counting. But if it is now, what happens is that, okay, then we need to cancel it, right? Because a new key has come. So this function will run after every new key is entered. So what we're going to do, we are going to say, okay, if there is something that is running, then let's do debounce dot cancel. We need to cancel it. But why are we having this error? Because we'll talk about this in a while, but then we need to add this how do you call it, exclamation mark in front of the debounce, because this is a function that may be null. So we need to recognize the nullity of this particular variable. So this variable can contain null, right? It's not really a variable. So this is a class. So we see a timer is a class. It's capital T. It's a class that is inside Flutter that counts. That counts times. So what happens is that it has a method called cancel. But then when you are running functions, classes, and then they can be null. They are variable kind of accepting a null. What happens is that you need to add a quotation mark to make sure that, to tell the system that, okay, this function that you have here, or this variable that you have here, has the potential of accepting null. So you need to, so the Flutter will keep that in mind. If you don't add it, you see that it's unconditionally. So we see that we are not adding this thing. It has an issue. It can be null. It can be null. So we need to add a debounce, an exclamation mark to make it recognize that there will be a debounce. That's just Flutter way. But then right now, what we have done fully over here is that when a new key enters, like the delayer, so the new key will enter the delayer, and then the delayer will check, okay, if something is, if that my timer is running now, currently running. So how do you know that it's currently running if it is not now? Because originally you have set it to now at the start, right? At the start it's not, but you check that, okay, it's not now. If it is not now, meaning it is running, right? So if it's not running, then let me restart. Let's cancel it. It will go back to now. This one will set it back to now, right? So send timer back to now over here, right? So now that's setting it to now. After you set it to now, what should happen? You need to restart it, right? So we are going to say debounce equal to, this is where we are actually setting the timer. So we say timer, then you set the duration. Let's end it up with this, right? Then we are going to set the duration, which is, let's say, constant duration. Then comma a function. Yes, so you can see this is what the timer accepts, right? We are currently accepting the duration and then a function that will run after that period has come, right? After that period has exhausted, what should run? So this is how a timer looks like, basic format. So you have to set the time that you want to set, and then also the function that will run after the time has elapsed. So we need to, you can set it to seconds, right? And say that, okay, it can be 1. So seconds is 1. If you want to do half a second, you can say, okay, half a second, like let's say milliseconds, that will be like 500 milliseconds. 500 milliseconds, right? But you can say, let's change this one to seconds. Let's change this one to seconds. So let's say 1 second for our illustration, right? But something small as 500 milliseconds is good, but it depends on your own choice, right? So 1 second, 500 milliseconds, you don't want users to be waiting that much. So before sending the request. So what we have done right now is that, okay, we say debounce. So when we restart, here we set you back to now. What happened is that we are going to run a timer again. So the timer will start again, right? For 1 second. After the 1 second, what should happen? That's what we are going to put inside here, right? After the 1 second, we know that, okay, nothing is coming again. Then that's what we call our search through function, right? That's what we call our search through function. That will take the keyword that will come. So this is the keyword that is coming. We want the delayer to first do the delay thing. So one thing is that it will check if the timer is currently running, right? By checking this thing. If it's not currently running, if it is currently running, like if it is not now, meaning it's currently running. But if it's not running, it will be now, right? So then you do a deep bouncer, right? If it's running, then you send it back to now again. Send it back to now. After you send it back to now, you need to restart it. This is where we are restarting with the time that we want. 1 second. So when it's restarting this thing, the value will not be now. The value will not be now. Now at the end of the 1 second, we need to now actually do the search. We need to actually do the search, right? So this means that in our unchanged value, we don't need to call search through directly. We need to call our delayer function. So let's go to our search button here. We are going to call, instead of calling um search through directly, we are going to call delayer. You can keep making it any other. People call it debounce function and all that, debounce function and all that, right? But these are delayer basically. So the delayer would take the value, the current value, right? Go and go inside it, go inside this function, the debounce, the delayer function, check if our debouncer is currently counting or not. If it is currently counting, meaning it will not be now. It will not be now, right? When it is not be now, because a new key has come, we need to restart the timer. So we need to cancel it, bring it back to now. When you bring it back to now, then you start the timer here, right? So you cancel it by bringing it back to now. Then you what? Start the timer. 1 second. After the 1 second, then this function will run. That's what the debounce are with, right? It's we have currently set it to 1 second, but then for improvement, you can give it 500 millisecond. That's half a second. But let's see that in action. I will intentionally increase the time so that we can see the effect of the search. But right now, let's see what happens. Okay. All right. So now I'm going to enter W. Right. You can see there is a bit of delay. Yeah, before it enters, because I stopped typing. First, if it's reactive immediately. It's reactive immediately. But right now, if I need to for 1 second before it comes. Let me increase it to 5 seconds. Maybe that will help you see appreciate the concept. Okay. So now let me do W again. 2, 3, 4, 5. Before a search will actually count. You see, it waits for 5 seconds before it's run. Let me go back to let me enter Z. So currently it's not doing anything. Yeah, so it waits for 5 seconds. Let me even when I cancel it, I need to get the original list, right? It will also wait for 5 seconds before it will come back. If you go to, let's say, Q, nothing exists in Q, right? So let's say what happens. Yeah, nothing happened. So it responds. Let me enter P. P also, it will wait for 5 seconds before it will show what P has. So now let's go back to let me just do 3 seconds. I think 5 seconds is too much for me. So what I will do is that I'll be entering stuff, right? I'll be entering stuff. Um, let's say Stella, for example. Stella, we have to wait for 3 seconds before Stella appears, right? So it's allowed to save time. So when the person is typing, currently I'm typing, right? I want to be typing more than 5 seconds or 3 seconds. Then you see that it has still not responded because it is seeing that detecting that I am still typing. So now when let me stop typing now, then the 3 seconds will now start, and then before it's giving me the response. I'm also cleaning, and then we wait before it sends that. That's for performance purposes. So but then let's leave it to milliseconds, right? Then let's say 500 milliseconds. That's half a second. Half a second is 500 milliseconds. Let's run this. Let's go with W. Yes, it's as if it's It's as if, but if I'm typing, it doesn't respond immediately, right? Maybe I waited small, right? So I'm typing now. I need to be typing more than 500 milliseconds so that it doesn't respond. So it's not responding now. It's not responding now because my hand is fast. I'm typing fast. It's still detecting I'm fast, typing fast. When I stop it, then there will be half a second that will pass, right? And this one, so I'm leaving it. Yes, but you need to know that the system is waiting for you to be done finishing before it start writing. Unlike before, let me go back and change this one to directly use the search through. So let's go and use a search through, right? Let me do R, and I'm going to tap Stella. So Stella, you see it is responding immediately. Stella, even though I'm typing, it has detected it. So it's calling it too early when the user is not done, meaning that every keystroke is going to be calling the backend. Every keystroke is going to call the backend, which is going to be like causing performance issues. So we run it back to R. Then what we have, let me now enter Stella. You see, it's not responding. It's not responding yet because I'm still typing. But the previous one was giving a distance, so it will wait when I stop typing before it will send. Yes, that's how you need to be adding the bounces to your functions.